Good day, Miss Jean Marbianes. I am Angel Star Bernardo Oliver, and I am here to present you or to prove you that the Earth is spherical, not flat or any other shape. So before I begin, let me discuss you what is the Earth spherical. Earth appears spherical from space. It's more accurately described as an oblate spheroid, or a sphere with a bulge at the equator. When we view from space, the Earth looks like a perfect sphere, and this is a common. So meaning to say, this is because the Earth's rapid rotation creates centrifugal force, causing a slight bulge at the equator and flattening at the poles. So next I have 4 scientific evidence that the Earth is spherical. The first one is lunar eclipse. Lunar eclipses provide strong evidence for Earth's spherical shape. The consistently circular shadow cast by Earth on the Moon during a lunar eclipse is a key indicator. Only a sphere can cast a perfectly round shadow regardless of its orientation, meaning the shadow shape of the Moon is direct proof that the Earth itself is spherical. So during a lunar eclipse, the shadow cast by Earth on the Moon is always a circle. This is true whether the shadow is a partial eclipse or a total eclipse, and whether the Moon is at the edge or center of the shadow. A lunar eclipse occurs when the Earth aligns between the Sun and the Moon, blocking sunlight from reaching the Moon and casting a shadow on it. The only shape that consistently casts a circular shadow regardless of the angle of the light source is a sphere. This is because all points on a sphere surface are equidistant from its center, which means the shadow cast will always be circular from any perspective. Ancient Greek philosophers like Aristotle recognized the circular shadow during lunar eclipses and used it as evidence for the Earth's spherical shape. In addition to lunar eclipse, other observations like the gradual disappearance or a shift at the horizon and the changing appearance of stars in the night sky also support the spherical shape of the Earth. The second one is gravity. Gravity is the primary force responsible for Earth's generally spherical shape, and its rotation contributes to the slight bulging at the equator and flattening at the poles, resulting in an oblate spheroid. Gravity pulls all parts of a celestial body towards its center, tending to make it spherical unless other forces are at play. So it causes the poles of Earth to be squeezed while the area along the equators. This lends to Earth being an oblate spheroid. Gravity exerts a force that pulls everything towards the center of mass. This force is what causes objects to hold the ground and is also responsible for shaping massive bodies like planets and stars. Because gravity pulls equally from all directions, a massive body tends to assume a spherical shape as the material is pulled toward the center. However, Earth's rotation introduces another factor. The conjectural force caused by the rotation creates a slight bulge at the equator and flattening at the poles, making it an oblate spheroid. The third one is airplane flight paths. Appear curved on maps because they follow the shortest distance between 2 points on spherical Earth, known as a greater circle route. This route, while appearing curved on a flat map, is actually the most efficient path in 3-dimensional space. So if you draw a straight line on a globe between 2 points, then flatten the globe, the line will appear curved. This is the same concept that applies to airplane flight paths. The Earth is not a flat surface, but a sphere. This means the shorter distance between 2 points on its surface is not a straight line, but a curve. On a sphere, the shortest distance between 2 points is a great circle, which is circle that passes through the circle center. Airplanes follow these great circle routes with a curve when projecting onto a flat map. Following a great circle route minimizes the distance traveled, saving fuel and time. So the last one is Eratosthenes' experiment. While primarily designed to measure the Earth's circumference, indirectly supports the understanding of the Earth's spherical shape by observing the angle of the sun's rays at differing locations along the same meridian and knowing the distance between those locations, he was able to calculate the Earth's circumferences. So according to Britannica, the calculation was based on the assumption that the Earth was a sphere, and the experiment success further solidified the idea of a spherical Earth. Aristophanes observed that at noon on the summer solstice, the sun cast no shadow in Siene, because the sun was directly overhead. In Alexandria, a location north of Siene, he observed that the sun cast shadow at an angle of about 7.2 degrees. By measuring the distance between Siene and Alexandria and knowing the angle of the sun's rays in Alexandria, Eratosthenes could calculate the Earth's circumference. So next, I have here 3 guiding questions. The first one is, how did ancient scientists figure out Earth's shape without modern technology? So these methods primarily developed by Greek philosophers and mathematicians, allow them to accurately determine the Earth's spherical shape and even estimate its circumference without modern technology. Ancient scientists deduced the Earth's shape through observation and circulations, notably like lunar eclipse, changing star positions, Eratosthenes' experiment, and ships disappearing half-first. So the second question is, why does gravity support a spherical Earth? So even without modern technology, people were able to deduce that the Earth is spherical through careful observation and logical reasoning. Gravity is the fundamental force that shapes planets into spheres by pulling matter equally towards their centers. So the last one question is, how can you disprove common flat Earth arguments with science? So for me, common flat Earth arguments can be disproved through scientific observation and evidence. So it's important to rely on verifiable scientific evidence and observation rather than misinformation when understanding the shape of the Earth. And that is all about my presentation. Thank you po.